the sound of a press stamping out metal. This is the sound of a drill cutting steel. This is the sound of a machine spinning wire. This is the whine of metal being polished. This is the purr of a lathe turning. This is the clank of a machine molding plastic. This is the crunch of clay being pressed. This is the roar of flame in an oven. This is the sound of metal being ground, being welded, being formed, being cut. These are the sounds of industry, the sounds of a manufacturing plant. This is the sound of Tektronix complex parts manufacturing operation, known as fabrication and molding. These are the sounds people at fabrication and molding live by. Without these sounds, production is dead.
John, this is Ash. The tooling for the new instruments should be done the early part of next week, and we should start producing parts immediately. Do you have that?
Tektronix manufactures a very special, complicated, and precise piece of electronic measuring equipment called a cathode ray oscilloscope. Building an instrument such as this is a complicated and difficult task requiring many mechanical parts as well as electrical components. Tektronix main plants are located in Beaverton, Oregon. Here, many buildings are devoted to the design and manufacture of the cathode ray oscilloscope. All of the metal parts and chassis, ceramic parts, plastic parts, the making of etched circuitry, plating, photo etching, chemical milling, and production of front panels are all carried out by the Fabrication and Molding Division of Tektronix. Most of these operations of fabrication and molding are contained in the metals building. Visitors to Tektronix are frequently surprised at our diverse manufacturing activities. It is somewhat unusual to find an instrument manufacturer who is also making many of the components used in the completed equipment. Many electronics manufacturers depend upon outside suppliers for most of their parts. Perhaps even more unusual is the extent of our fabrication facilities. Fabrication and molding. F&M consists of a number of operating areas. There is production, production planning, manufacturing engineering, ceramics production, quality assurance, and of course, personnel. The F&M production area consists of plastics, electrochemical, precision mechanical assembly, metal fabrication, and metal finishing. Two products are manufactured in their entirety in F&M. The camera for recording the oscilloscope trace, and a transport for our instrument. Most of F&M's operations are involved in producing thousands of different parts. These are used in the manufacture of cathode ray tubes, the manufacturing of accessories, capacitors, parts to customer service, parts to our overseas operations, and parts to our instrument manufacturing plants 1, 2, and 3. All of these operations tie together to aid in the production of our main end product. A lot of planning and a lot of work go into the production of the thousands of structural parts used in the oscilloscopes. F&M's manufacturing engineers work in close liaison with the instrument design engineers as new instruments are being developed. These production-oriented engineers determine whether a product can be manufactured, how economically it can be made, and determine the best process. Later, these men will design the tools and prepare processes for the manufacture of the metal, ceramic, and plastic parts. When an instrument is ready for pilot production, manufacturing engineering is responsible for building tools to produce parts for the new instrument. We continually ask ourselves the question, is this part or tool available on the outside, or is it necessary to manufacture it ourselves? Where a satisfactory part is already available, we usually find that it is best to purchase it. However, often such parts are not available or are not manufactured to the tolerances that we require. Tungsten carbide dies and jigs are required for ceramic parts. Tool and die makers, advanced in their craft, prepare these with painstaking care. Expert plastic die makers prepare dies for plastic parts. Delicate work and attention to detail is needed in milling and polishing this special die, which will be used to mold a plastic knob. The cost of the steel used may be only a few dollars, yet the finished die may be worth hundreds or even thousands of dollars. Many dies are needed. These cabinets contain dies of all shapes and sizes to make hundreds of different intricate precision parts. The completed parts and jigs are delivered to the shop area. and the parts making process begins. Thousands of cylindrical parts are turned out daily on the Metal Fabrication's installation of 6 spindle screw machines. The metal fabrication and metal finishing areas carries the biggest parts manufacturing load, turning out millions of parts. Aluminum is used in the manufacture of structural parts. It's lighter than steel and non-magnetic. A steel chassis might become magnetized. This would distort the trace displayed on the cathode ray tube. Aluminum flat stock is sheared for panels, sub-panels, chassis, brackets, and other structural parts. Holes are punched in the sheared stock to exacting tolerances. Parts are formed to usable shape. The aluminum is punched and sheared and bent and drawn and machined and formed into many shapes and sizes. There are big parts and small parts, simple and complex, but each must be accurate in size and shape. Each has a definite purpose. The parts are now loaded onto an automatic conveyor system. A caustic etch gives them a satin matte finish. This automatic machine was designed and built by Tektronix. Another conveyor line. The parts are cleaned with sprays of hot water and detergent. They are rinsed. They are dried. A high voltage charge attracts the fine particles of paint to the metal. This is known as electrostatic painting. Every surface receives a uniform coating. Brackets and chassis must be marked and identified. Some of the marking is applied with silk screens. Most of the markings are applied with a printing press. And a jig. A conveyor system carries them through an overhead oven for drying and on into the packaging area. Here, final inspection and packaging takes place. Tektronix had trouble locating a source of coaxial cable that would meet our specifications. No outside supplier was willing to undertake the manufacturing of cable to our exacting requirements. We had no choice but to make it ourselves. Plastics now produces 25 different types of plastic-coated cable. All types meet rigid specifications and are produced at less than 1/5 the cost of purchased cable. A vinyl jacket is being extruded onto this cable, and its thickness is being rigidly controlled. In plastics, highly experienced plastics engineers work constantly to develop improved plastic parts, including knobs, structural parts, packaging materials, plastic-covered cable, and many other items. These expandable polystyrene beads are placed into a mold. Steam is injected. The plastic expands, taking on the shape of the mold. This will be used for packaging a delicate part. Plastic parts are molded to exact tolerances. Many types of plastic materials and methods of molding are used. Plastic materials such as Delrin, polypropylene, and polyethylene can be injection molded under heat and pressure. Here, a nylon component is being produced by injection molding. Precision measurement of the oscilloscope trace can only be as accurate as that of the ruled overlay or graticule in front of the cathode ray tube. Each graticule is hand scribed. Knobs are compression molded from a urea formaldehyde thermoset material. Red knobs, black knobs, and gray knobs are produced by the thousands. Hundreds of hours of tooling time, careful attention to detail, and the selection of the best materials assures a product which reflects Tektronix quality. One of the earliest industries known to man was the production of ceramics. But the modern precision ceramic part is a far cry from the early pottery vessels. Because of the excellent electrical insulating qualities, ceramic parts have bloomed to full usefulness as an ideal mount for electronic components in Tektronix manufactured instruments, for components for the cathode ray tube, a new application, even a ceramic envelope for the tube. At F&M's ceramics plant, skilled workmen mold from processed clay more than 30 different ceramic parts for the oscilloscope. Ceramic strips are turned out on a production line basis, starting with the mixing of the clay. pressing it into shape. Applying a high-quality glaze. Firing in this specially designed kiln. Silvering the notches so solder may be applied. Applying solder to the notches to receive the wires. And finally, a rigid inspection to maintain the high quality. Ceramics can be produced to precise tolerances. Ceramics are playing a part of increasing importance in the electronics industry. The electronics industry is moving at a rapid pace. To hold a position of leadership in the industry requires increased research to develop new methods to produce a better, more uniform product. Electrochemical has pioneered in the use of new methods and procedures to produce such a product. While some of Tektronix plating needs are still handled by outside vendors, Electrochemical handles all precious metal plating, including gold, silver, rhodium, and nickel. Functional characteristics demanded in precise electronic instruments make plating an extremely critical operation of parts manufacture. By having its own plating facilities, Tektronix can control quality. A metallurgical laboratory controls plating thickness, an analytical laboratory keeps chemists on hand to control plating solutions. We can control delivery and cost, and availability of all kinds of plating materials. Etched circuitry, one answer to high component density, and uniform electrical performance now is being used in some Tektronix instruments. The making of etched circuit boards involves the use of photography, etching, and plating. Use of etched circuit boards is growing rapidly, making this part of electrochemicals operation increasingly important. This delicate part could not be produced by ordinary machining. Chemical milling or etching permits us to make it. When research or design engineers need 2 or 3 parts for experimental purposes, these can be produced by chemical milling, thus saving tooling costs to manufacture a small number of parts. Early in Tektronix history, panel craft, now a part of electrochemical, was established to make front panels for the oscilloscope. Only the highest grade mirror finish aluminum is used. Since the quality of the instrument is reflected in the front panel, anything less than a perfect panel is rejected. The aluminum is anodized, producing a very hard surface, which makes the panel durable and much less susceptible to scratches. Year after year, Panelcraft has met the challenge by stepping up its production to meet the demanding requirements for more and more high-quality front panels. The assembly of finished accessories, when the assembly is strictly mechanical, is done in fabrication and molding. Here is a product which has won honors for design and quality. It is used as a transport for the oscilloscope. The entire production takes place in fabrication and molding. Another product manufactured entirely by precision mechanical assembly of F&M is the Tektronix camera. This camera is used to record an oscilloscope trace, a trace that may last for only a fraction of a millionth of a second. The making of these special cameras requires the highest degree of skill and workmanship. There can be no compromise in optical or mechanical tolerances. Quality begins with care in engineering and design, with the selection and testing of materials used, and by close attention to detail in each manufacturing operation. But these alone will not assure a quality product. Each step must be closely watched, and each part must be carefully tested. Quality assurance sees to it that each part, each operation, each batch of material meets rigid specifications. To build a quality precision electronic measuring instrument such as the oscilloscope requires close attention to many things. It requires close cooperation between research, instrument design engineering, production planning, pilot production, cathode ray tube production, fabrication and molding, and instrument manufacturing and test and evaluation. We at Tektronix pride ourselves on the quality of our instruments. Tektronix quality is more than just a phrase. It is a living standard of excellence. These are the sounds of careful workmanship. These are the sounds we in fabrication and molding live by. These are the sounds of progress.